To find the standard deviation, we're going to use something called, surprisingly enough, the standard deviation formula. And I'll write out the standard deviation formula here. And what you'll see is that it looks pretty similar to a different formula we just looked at. So we call the standard deviation S, and we find it by looking at the square root of all this stuff. So we have the square root of the sum of our squared deviations over n minus 1. In other words, we have the same exact formula that we did for variance, we're just going to take the square root of it now. So in order to find what's in here, you write out your observations, you subtract the mean to get your deviations, you square them, you add them up. So now we have this expression here of the sum of your squared deviations, which is on the top of our standard deviation formula. Divide by n minus 1, which we already did over here. And then finally, take the square root of this. So if you want to find the standard deviation, the only thing that you're going to do from here is to take the square root of the variance. So again, everything under this square root thing is the same as the equation for variance. So to find the standard deviation, we're just going to take the square root of the number that we already found for the variance. So our variance here was equal to 2.27. So in order to find our standard deviation, and let's make sure you can see this is s squared for this one. To find our standard deviation, we're going to plug in our variance under the square root sign, take the square root of it, and we'll have our standard deviation. So if you take the square root of 2.27, you get 1.51. And that's your standard deviation. So it looks like a big clunky formula, and you do have to go through all these steps to get there, but once you know the variance, you're just taking the square root of it. And here we have a standard deviation of 1.51 arrests. You can interpret this as meaning that in this sample, the average distance between an observation and the mean is 1.51. So that's, on average, how far away everything is from the mean. So that's a pretty straightforward interpretation, especially compared to what we had for variance here with our squared arrests. So those are the different ways of looking at variability and how to calculate them. And the next thing that I'm going to do is give an example that's going to hopefully make all this and then also some of our measures of central tendency a little bit more concrete.